when we left off last time, you had a bunch of homework, which we need to go over. First was the appliance installation practice. And you had to use the good practice book and the IFGC, so the International Fuel Gas Code, to answer the following questions. Okay, so we're just going to kind of go through these and make sure everyone knows where to find the answers. That's the whole key to this test, is just knowing where to find the answers, because it's an open book test. So we'll go through these. So let's go ahead and start here. Kurt, on this one, where did you find the answer for this first question?
Yeah, I got page 65, and it says, unless equipment is listed for such installation.
So it's this blue book here, and what you want to do is when you find these answers, highlight them. That way when you go in for test day, you know where to find them at, or tab them, or some way to figure out how to find them. So that was page 65. Okay, very good. Kurt, we'll just have you do the next few. Where'd you find the answer to number 2 at?
I got page 65.
Okay, so
level workspace 30 inches deep and 30 inches wide.
Okay, so they're asking you about the workspace. And right down here, appliances, okay, they give you 30 inches. They give you all these different dimensions of stuff, but that one right there was a level workspace 30 inches wide and 30 inches deep, shall be provided on the control side of the equipment. And you can also find that in the International Fuel Gas Code, section 306.4, okay? So you can take this blue book and the fuel gas code and all these notes that we're taking into the exam with you, okay? All right, Kurt, what did you come up with on number 3? Where'd you find that one at?
Okay, it says when a gas appliance is installed in an attic access opening, the opening must be no smaller than 30, and the appliance shall be no further than 22 from the opening, and that was page 66.
Okay, so
that's now the inches.
Right there. Okay, so the passageway for the gas appliance installed in an attic shall be at least, so this is something I'd want to highlight or know how to get to, at least 30 inches high and 22 inches wide, and have a continuous solid flooring not less than 24 inches wide and not more than 20 feet in length. So that means from your opening to your equipment, you can't go more than 20 feet. There are some exceptions though. So one of the exceptions is where the passageway is not less than 6 feet high for its entire length. Your furnace could be 50 feet, okay? So make sure you understand the exceptions. You're going to be asked all kinds of questions just like we are here, and the trick to it, guys, is just knowing where to find the answers. The answers are all in there. All right, Kurt, keep going for a bit. What'd you find for number 4?
For gas appliances installed in an attic, in attics and crawl spaces, what must be permanently installed at or near the equipment? And I got this on page 66.
Right there, in attics and crawl spaces, a permanent electrical outlet and lighting fixture. And it's also in the IFGC 306.4.1, okay? All right, number 5, where'd you get on that one, Kurt?
Okay, we're on page 67. So the gas appliances installed in rooms with exhaust fans must be protected from what? It says the possibility of the fan pulling a downdraft on the appliance vent.
We got to prevent them from backdrafting, right?
Yeah.
That's basically what that's talking about, or worst case depressurization, CAS. All right, number 6, what'd you come up with on that one there, Kurt?
Okay, it says when installing a gas-fired appliance in a garage, the appliance source of ignition must be less than 18 inches above the floor.
Okay, so they're talking about equipment appliances having ignition source. That ignition source has to be not less than 18 inches above the floor in hazardous locations, public garages. What do you think the reasoning behind that is? If I had gas fumes in my garage and they were dropping down low and there was a furnace out there or a water heater, the pilot light or the ignition device could set that off if there were gas fumes in the garage, right?
Yep.
So they want that ignition source to be up above because gasoline fumes are heavier than air, will drop down low. Number 7, what is the one exception to question number 6?
Let's see, listed as flammable vapor ignition resistant.
Okay,
Page 7.
right there. So this is something I would highlight or tab or whatever, so that on test day you can quickly find it and go back to it. Every answer to every question on the test is located in one of these books somewhere. Okay, so there is an exception. Number 8, what'd you come up with on that one, Kurt?
Says list at least 3 areas where gas-fired appliance may not be installed. And I got sleeping rooms, bathrooms, toilet rooms, and surgical rooms. And I think we had discrepancies because I had 2 page numbers. I got 48 on the old good practice book and page 69 on the newer version. I would say.
If you got an old book, it's on a different page. So the book I'm working off is the blue one. If you have the orange one, you're right, it's on page 48. But they talk about hazardous and prohibited locations, and they have some exceptions. Okay, so make sure you know the exceptions, because you may be asked a question about the exception to the rule. All right. Okay, we're gonna have you keep going for a little bit more, Kurt. So about number 9, what'd you come up with on that one?
It says, when is it permissible to install a gas-fired appliance in a bedroom? Dedicated enclosure, combustion air out has to be outdoors, solid doors with weather strips.
Okay.
Page 9 and 70.
So they talk about when it is acceptable to install a combustion appliance in a bedroom or a bathroom. We run into that a lot in weatherization, don't we? Now you know where to find the answer to the question. Okay. All right. Number 10.
Let's see, list at least 7 areas where you may not install a return air inlet. I got closet, bathroom, toilet room, kitchen, garage, toilet room, and furnace room.
Okay, right there. Return air openings shall not be located in those areas. Okay. So what'd you come up with on 11?
Okay, vented wall furnaces shall be located so as to prevent what? Fire hazards to walls, floors, and combustible furnishing outdoors.
Okay.
Right 70 and 71.
Right there, they talk about vented wall furnaces, and they also tell you where else you can find the answer, IFGC 608. Okay. All right, good deal. Okay, and number 12, what'd you come up with on that one there, Kurt?
When is it permissible to install ductwork on a suspended unit heater? When it is listed for such use.
Okay.
Page 71.
All right. A unit heater shall not have ductwork attached unless listed in the installation for instructions for such use. What'd you come up with on 13, Alan?
13, a hot water boiler must have what minimum required safety devices? Aquastat, a pressure temperature gauge, pressure relief valve, proof of flame, and a low water cutoff. Page 72.
Okay, very good. So again, the information is there. You just have to know where to find it. Okay, what'd you come up with on 14 there,
14,
Al?
is it permissible to use an unvented space heater as a sole source of heating in a dwelling? No.
No.
Page 72.
Page 72. Okay. Unvented room heaters. We all know that right there. Okay. Shall not be used as the sole source of comfort heating in a dwelling. Can they be used as a backup source of heating in a dwelling? As long as they meet these rules, right? There's a set of rules that govern whether or not we can use them as a backup source of heat. Okay. So you want to know where to find those rules. You're never going to be able to memorize them all. Hell, I can't memorize them all, and I've been doing this for 40 years. So, but I know where to find them. So, all right. Alan, 15. Where'd you come up on that one?
An unvented space heater installed in a bedroom must be no larger than 10,000 BTUs an hour.
Okay. So
Page
again,
73.
talk about the codes for if you're installing them in bedrooms or bathrooms. Okay. So you're going to want to know that stuff there, where to find it, highlight it or tab it or whatever you've got to do so that you know where to get to it quick on test day. All right. Number 16, Alan, what'd you come up with there?
All unvented space heaters must be equipped with an oxygen depletion sensitive safety shutoff system. 73.
Again, right there. It's all just a matter of knowing where to find the information. All right, number 17, what'd you get on that one?
Oh, it must be anchored in the upper 1/3 and lower 1/3 of the vertical dimensions because
Okay.
of earthquakes. For page 74.
Seismic supports. Okay. Right there, talks about it. It's also in the International Plumbing Code, 502.4. Okay. All right, good deal. Okay, let's see, 18.
When is it required to install a tempering valve on a water heater? When used for space heating and water supply. Page 75.
Page 75. So they talk about a tempering valve to limit the temperature. Okay. So water heaters used in combination of space heating and potable water supply, so on, so forth, and etc. And they give you other places where you can find the exact same information. So the International Fuel Gas Code, the International Mechanical Code, International Plumbing Code. Okay. All right. Cool. 19, what'd you come up with on that one?
All water heaters shall be equipped with a pressure temperature relief valve, which has a maximum setting of 210 degrees Fahrenheit or 150 PSI.
Okay.
Page 74.
Okay, good deal. Right there. Let's really talk about that. Okay. 20.
Define temperature and pressure relief device. Actuated valve or rupture member designed to automatically relieve excessive temperature and pressure. Page 29.
Page 29. Okay. Pressure relief device. So the start of the book is where they have the definitions. Okay. So anytime you get asked a question like that, define something, you need to go towards the start of the book. All right, number 21, what'd you come up with there?
Which gas cooking appliances shall not be installed in a dwelling unit? Commercial. Anything that's listed as commercial.
Okay, and listed as commercial, and we found that on page 75, correct?
Yes, sir.
Okay. All right, so right there, listed and labeled for commercial occupancy shall not be installed in dwelling units or within area where domestic cooking operations occur. So again, this is all just about knowing where to find the information. It's all there for you. Number 22, what'd you come up with on that one?
When installing a clothes dryer in a closet, it's required have an opening having an area of not less than 100 square inches for makeup air.
All right.
Page 75.
Okay. Right there. Very good. Okay. All right. 23, what'd you come up with on that one?
Unless permitted by the manufacturer, exhaust duct shall not exceed 35 feet. 76.
Okay. So they talk about how long your dryer vent can be, right? Okay. Unless the manufacturer says otherwise. Okay. All right. 24, what'd you come up with on that one?
Closed dryer exhaust ducts shall not be joined together with screws or similar fasteners.
Okay.
76. Anything
Right.
to disrupt the flow and pick up dust.
Okay. Oops, that's not the one. Where's it at? There we go. Shall not be joined with screws or similar fasteners that protrude to inside of the duct. Why do you think that would be a problem?
Because your dryer has all the lint and dust that's trying to push out, and then you don't want to build it up and have a fire.
Yeah, you got those screw tips in there, and it's going to catch all the lint and crap, right? Okay, that's the intent behind the code. We don't want to cause a clog in there or start a fire. Okay, 25. What'd you come up with on that one?
Exhaust ducts shall terminate on the outside of the building and be equipped with a backdraft damper. Page 76.
Right there, they talk about that one. Okay. So again, guys, it's just about knowing where to find the information. It's all in there if you just take the time to read it and look. All right, we're almost through this one. 26. What'd you come up with on that?
Material and size restrictions for a closed dryer exhaust duct. They need to be metal and have a minimum thickness of 16 thousandths of an inch and duct size no less than 4.
So smooth interior finish and shall be constructed of metal minimum of 0.016 inch thick and shall be 4 inches nominal diameter. Smooth interior finish. Does that mean you can use flex to vent a dryer?
It's a trick question. No.
No, only the connector. The first 6 feet. Okay. Or is it 8 feet? 6 or 8 feet. And then the rest has got to be smooth. All right. And metal. All right. Very good. Okay. 27. What'd you come up with on that one?
27. Am I missing a paper? Oh, it's in the wrong spot. Transition ducts.
Okay.
Used to connect the dryer to the exhaust duct system shall meet what requirements? Single length listed with the Universal Laboratories guy. Maximum of 8 feet and not concealed in construction. Page 76.
Okay, page 76. Okay, so again, transition ducts use the connector to the dryer. Okay. And on your sheet here, if you're writing down like you are, where did you find that information on test day? That's going to help you because you're going to see questions just like this, and you can go, oh, okay, yeah, ducts. They're over on, they talk about dryer ducts on page 75 and 76, so you can quickly get to the place you need to be to find the information. All right, why don't you just go ahead and finish us off there, Alan? What'd you come up with on number 28?
28 I found in the International Fuel Gas Code book on page 27.
Okay.
Minimum allowable internal diameter 3/4 inch for condensate.
Good deal. That was a trick one. That is not in the good practices book, but it is located in the IFGC section 307.3. Okay. So there are going to be some questions on the tests that won't be in the good practices book. They're going to be in the IFGC. Okay, good job. That was a trick one I threw at you. Okay, what about 29?
When does category 4 condensing appliance require the installation of an auxiliary drain pan? It's also on page 27 of the IFGC, and it's if the damage to the building components can occur.
Okay. How many of you other guys were able to figure out you had to go to the IFGC to get those answers? Good. So you go out thumbs up and nodding. Good. Okay. So yes, you will need the IFGC to get some of the answers. All right, and Alan, our last one, please.
Define category 4, page 17 of IFGC. An appliance that operates with a positive vent static pressure and with a vent gas temp that is capable of causing excessive condensate production.
Okay, and it's also on the good practices book, page 32. Whoops, want that, want my highlighter. Okay, good deal. Okay, does anybody have any questions about appliance installation and where to find the answers and all that type of stuff? Next, we had a combustion air practice. So we had a combustion air practice exam. And same deal, you had to use the good practices book and the IFGC to answer the following questions. So we'll go ahead and Jordan, can you hear me okay?
Yeah, can you hear me?
Yes, sir. Okay, why don't you go ahead and take us through this one. Number 1, define combustion air. Where did you find it?
Page 17 of good practices, and air necessary for complete combustion of fuel.
Okay, so he went to the definitions page. Scroll up here. Combustion air. Okay, page 17. It's also in the IFGC, page 10. So I would highlight that stuff. Okay, number 2. What'd you find out on number 2 for us, Jordan?
Space in which operation of an exhaust fan may adversely affect flow of combustion air. Found it on page 78 of good practices, section A.
Okay, so we go to page 78. Talking about combustion air openings. Hey, that's section 5. Anything to do with combustion air is in section 5, okay? So you go and find the information you need and highlight it. All right, good deal. And number 3, Jordan, where'd you get the answer for that one?
Page 78 of good practices.
Okay.
4 appliances are fireplace, clothes dryer, exhaust fan, kitchen ventilation.
It's also in the IFGC in 304.4. So right there, they talk about exhaust fans, kitchen ventilation, clothes dryers, fireplaces. Okay. All that CAS stuff, right? Okay. Number 4, where'd you find that one at?
Page 78 as well in good practices. The answer is no, never.
Never. Okay. Never. Okay. Good deal. All right. Next one, number 5. What did you find out on that one?
3 inches, also on page 78.
Okay. So it's telling you when you make or use a combustion air duct, it can never have a dimension on it that is smaller than 3 inches. So you couldn't have a 2x10 combustion air duct because it has a dimension that's smaller than 3 inches. Does that make sense to everybody? Okay. You can never have a dimension that's smaller than 3 inches on a combustion air duct. Okay. All right. Good deal. All right. Number 6, what'd you come up with there?
Hazardous location found on page 78 of good practices in section E.
Okay, combustion air shall not be obtained from any hazardous location or from any area in which objectionable qualities of flammable vapor, lint, dust are given off. Combustion air shall also not be taken from refrigeration or machinery rooms. 7. Okay, what'd you come up with on that one?
Any location considered to be a fire hazard for flammable vapors, dust, and combustible materials. Found it on page 21 of good practices.
Okay, so 21 of the good practices. Okay. So again, that's where all the definitions are at. So if they're asking you a definition question, you're back at the beginning of the book. Same thing with the IFGC. The definitions are all back at the beginning of the book. Okay, number 8. What'd you come up with on that one?
Galvanized steel. I found that on page 79.
Okay, so they talk about what they must be constructed of, page 79. Okay. shall be constructed of galvanized steel, complying with chapter 6, blah, 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 exception. And they have an exception, okay? We can use joist spaces for combustion air, as long as we don't have to tear out a bunch of fire blocks, okay? Also note this one, okay? Flexible duct is not allowed. And we just discussed those two there. So 9, what is the exception? And 10, what may not be used for combustion air ducts? Okay, we just talked about those there. How many of you have seen jobs where they use flexed for combustion air? Seen a ton of them. It's not allowed. Okay, all right, let's go back over here. Okay, so we're back down. We're down to 11 now. So what'd you come up with on 11?
On 11, it shall not be screened. Page 79.
Screened, page 79. So they're talking about terminating in attics. Okay. Shall not be screened. Okay, very good. What did you come up with on 12?
Number 12, I think I must have just spaced it right there. I didn't write anything down on 12.
Okay, so on 12, it's on the old good practices book.
Oh, I couldn't find it. This was one I think I emailed you about.
Page 55 of the old good practices book. And why it didn't make it into the new one, I don't know. But if you have the old orange good practices book, it's on page 55. So if you got to be 6 inches above the insulation and you have 18 inches of insulation in there, how far above the ceiling must you be? So that would just be simply 18 plus 6, right? Would be the answer to that. So just make yourself a note there that your combustion air ducts must be 6 inches above the insulation, okay? And in this particular case, you had 18 inches of insulation. So from the ceiling up is 18 inches, and then you got to go 6 inches above that, right? Does that make sense to everybody?
Yeah.
Okay. All right. Good deal. All right. 13. What'd you come up with there?
The answer I have is no, and I found it on page 80 of Good Practices.
All right. Page 80 of the Good Practices. Okay. Right there. Okay, so they're asking you, after lining a masonry chimney with a metal liner or PVC exhaust, is it permissible to use the surrounding space to provide combustion air? No, you cannot do that. How many of you have seen that done a lot? Okay, I've seen that done a lot out in the field. That's no, you can't do it. Okay, number 14. What'd you come up with there?
Never. Also on page 80.
Page 80. Okay, never is never allowed. Okay. All right. Okay, number 15. What'd you come up with on that one?
Wood at 25%, metal at 75%, also on page 80.
Okay, so this is where we start. We kind of left off last class talking about this and doing some examples. And we're going to go through all the combustion air practices, and you should all be grandmasters of combustion air calculation by now, but there's where they talk about that. Okay. Number 16.
1/4 inch, also on page 80.
Okay, again, anything in combustion air is going to be in the combustion air section. We'll talk about it, right? Yeah, my mouse is being dorky. Anyway, come on. Anyway, all right. Next one, 17.
If volume of room is equal or greater than 50 cubic feet per 1,000 BTU, combined input was found on page 81.
Okay, very good. I don't know why my mouse is being retarded today. Remember, that was that confined space rule, okay? Or adequate volume, confined space. So we find that information there. And you're going to need to know that and the other stuff coming up in order to get through the practice exams I gave you. So, okay, number 18, what'd you come up with there?
Openings between them have no doors, also on page 81.
Okay, so again, page 81, they talk about rooms communicating directly with the space, as long as there's no doors, okay? Can we include bedrooms in that? No, never. Can't include bedrooms. Okay, all right, very good. 19.
Less than 0.40 air changes per hour.
Okay, what Turner talked about last time. You guys do a really good job of making houses tight. When you start getting below this point, the house is too tight and you can't pull combustion air or use inside air, okay? And there's a formula to figure it. If you know your ACH 50, you just use the multiplier. There's, what the hell do they call them, Turner? The wind shielding factors or whatever, or the N factor. And there's a formula to figure. But basically what we're finding is if you guys tighten a house to where the ACH 50 is 5 or lower, that house is going to be too tight and you're going to need to pull combustion air from the outside. If I was king of the world, we'd just get rid of appliances that need combustion air and we'd put direct vent and everything, but I'm not king of the world yet, so. All right, 20, what'd you come up with there?
20, I have opening at the upper 12 inches and the lower 12 inches, free area no less than 1 square inch per 1,000 BTU, and a minimum of 100 square inches, and I found that on pages 82 and 83.
Okay, 82 and 83 talk about that, okay? And these are all important codes you're gonna need to know to get through the test and the stuff coming up that we're doing here. Okay, let's see, where are we at? 21 now?
Yeah, 21 I have written down 2 permanent openings from page 85.
Okay, page 85. So we're talking about the combustion air codes and the 2 opening method. Okay, all right, and 22. There.
1 square inch to 4,000 BTU on page
Okay.
85.
Very good. So 2 opening methods. Okay. And 23, what'd you come up with there?
1 square inch to 2,000 BTU from page 88.
Okay. Okay, so when using 2 opening methods to obtain combustion air from the outside, what is the minimum free area of each opening when configured vertical or direct? Oops, that's horizontal, sorry. Let's go back up to our vertical or direct. Right there. That's the one we want for that one, okay? All right. Let's see, 23. Is that where we're at? 23.
24, I think.
Oh, sorry. There we go. 24.
1 square inch to 3,000 BTU. Also found on page 89, 88. No, 89.
9, yep. So if you're going to use 1 opening, okay, so you have the option to use just 1 opening, but if you do use 1 opening, you got to follow a different formula, and there's a few other things that go along with that, okay? So you're going to want to know and understand that stuff, and again, that way when you review the video, you'll know where to find it. 304.11.8, okay? And that actually says combustion air intake openings located on the exterior of a building shall have the lowest side of such opening located not less than 12 inches from the finished ground, okay? All right, good job. Any questions about that? Basically, that's all it is just knowing where to find the information and having your notes well put together, your books well organized so you can find the stuff and get in there and get to it. If you walk into the exam with like a whole bunch of papers crumpled up and stuffed in your pockets and stuff, they're not going to let you bring that in. You've got to bring in a well put together book. And I'll show you. I'm going to show you. That's what I got my PowerPoint for, is to show you what your book should be looking like. But we're going to finish up some of these practice things here and get them out of the way.
I'll be honest, that's going to be everything because I did this and tried to review it later in the week and I had forgot 90% of it.
And that's it. If you don't do this every day, you can go. It's with anything. You can go through a class.
Alan forgot too. And Blake.
If you're not doing it every day for a living, you forget. So that's why we're videoing all this, so you can go back and review. That's why you're building this book, so that you can go back and review. Okay? Because yeah, if you're not doing this every day, you'll forget stuff real fast. And there's a lot in here to remember. Like I said, I've been doing this for 40 years. I don't have this stuff memorized. I turn to the code book all the time. Okay, Robbie, were you able to get this grill sizing practice done?
Yes.
Okay, so let's go ahead and go through this. What did you come up with on this first one here?
I came up with 75 square inches.
75 square inches, that's exactly right. And could you explain to us how you did your math? What'd you do?
10 times 10, let's see, got a metal grill here, so 10 times 10 equals 100, and times that at 0.75, okay, 100, then times that with 0.75, and I came up with 75 square inches.
75 square inches. Okay.
Yeah, there we go.
Yep, 75 square inches. Okay, and the examples are right up here with the formula. Okay. So we're just going to go ahead and go down, and Robbie, I'll have you tell me. We'll just kind of pick on everyone a little bit. Robbie, what'd you get on number 2?
Okay, 12 times 12 is 144. With the wood grill, you times that by 0.25, and I came up with 36 square inches.
Okay, perfect. 36 square inches. Okay, what'd you come up with on number 3?
Okay, again, 12 times 12 is 144. It's a metal grill, so you times that by 0.75, and I came up with 108 square inches.
108 square inches. Very good. And if there's any one of you guys who came up with a different answer, you need to holler out and let me know so we can make sure that you understand the math that you need to be doing. So Robbie, keep going. I'm going to have you do a few more of these for us, please. Number 4.
Okay, 10 times 10 is 100. It's a wood grill, so times that by 0.25, and you get 25 square inches.
Very good. Okay. What'd you come up with on number 5?
Okay, 8 times 12 equals 96. Metal grill, times that by 0.75, you get 72 square inches.
Okay. Go ahead on this next one, number 6. What'd you come up with on that one?
All right, 14 times 14 equals 196. It's a wood grill, so you times that by 0.25, and the answer is 49 square inches.
49, very good. Okay. I know this seems very repetitious and boring, but that's how you get good at this stuff, is this repetition, okay? Because you're going to have to know how to do this, and this is going to be your, like you said, you walk away from it for a month and you forget how to do it. Well, now you can go back and you have notes, and you've done it so much that you can go back and remember how to do it. And on test day, you can have these notes with you. Okay, Robbie, number 7, and then I'll pick on someone else. So what'd you come up with on number 7?
Okay, again, 14 times 14 is 196, but we're using a metal grill this time, so it's times 0.75, and it's 206.5 square inches.
206.5, are you sure?
Is that wrong?
Well, hold on, let me see.
I might have got that. I guess that.
Okay, so we have a 14 times 14, 196, and it's metal, right? So
Yes. Times 0.75.
times 0.75. You're,
Oh, I'm off. Okay.
What'd you
Whoops.
do wrong? Do you know where you made your mistake?
Not off the top of my head. Can you tell me?
What answer did you come up with again?
206.5, unless I put in the wrong formula.
Yeah, I think you did the formula wrong or something. Okay, so let's just go
Okay.
over it again. So it'd be 14 times
By 4.
14. Okay, and because it's a metal grill, we do 0.75, and we come up with 147.
Okay.
I wonder if maybe you divided or did something or fat fingered it or something.
I might have. I might have.
I find that's usually what happens in this case on those ones. So that one should be 147. Okay.
Hey, my bad.
No worries.
Don't take that, Robbie.
Better you make your mistakes here than on test day. Okay. All right.
This is
all right.
good.
Okay, Robbie, thanks for doing those ones. We'll go to someone else. The three of you that don't have cameras on, damn it. You know the rules. You're supposed to have your cameras. So who is
I didn't know
that. We got to be like we're really in a classroom now, in the new normal.
Tim
Okay.
said he got no camera or volume, so he told me to tell you that.
Say that again.
Tim told me to tell you he ain't got no camera or volume.
Okay. Isaac, were you able to get this grill sizing practice completed?
No, but I got a calculator right here in front of me. I could do that real fast. Give me a second.
Okay. Well, go ahead and figure out number 8 for us then.
So we got, it looks like 8 by 16. And then we divide by 0.7, right?
No, look at the top and look at the examples.
I can't look at the top. They won't let me scroll up.
Well, let me scroll up. Okay, it's a
Oh,
wood
let's see.
grill.
Okay.
So
Oh,
8
it's wood
by
grill.
16. It's a wood
Okay.
grill.
Uh-huh.
So it only has 25% of its free area. So you would take 8
Gotcha.
by 16
Yeah.
and times 0.25.
Okay. So 0.16 times 0.25. And then, so I got 0.4 is my total there. So that's what I divide the 8 by 16, right?
No, so take 8 by 16.
Uh-huh.
Okay, so in your calculator, do 8 times 16.
Okay.
Okay.
Mm-hmm.
Let me move my calculator over here so we can follow along. So 8 times 16 equals 128 square inches.
Okay.
But because it's a wood grill, it only actually has 25% free area, right? Because of all the louvers.
Yeah.
So times that number by 0.25, and I come up with 32 square inches. That's what I actually have of net free area, 32 square inches. Does that make sense? It's the blocking effect of the louvers.
Yeah.
Okay? Because we have louvers in it, we don't have a big open hole, so we lose a lot of area. And especially with wooden grills, they have to make them heavier and thicker. Okay. All right. Let's have you do number 9 for us. How you going to handle that one?
Okay, so that one's a metal grill. So we'll go 12 times 14. And then times that by the 0.7, right? So 117.6. So we round that up or no? So we go 118 square, or do we round down?
So did you see what I just came up with?
Yeah.
Okay.
Oh, you did 0.75. That's why. My bad. My bad.
5. So remember
Adding.
the examples at the top of your page there. So again, we've got a metal grill that's 12 by 14. So I go 12 times 14. And because it's a metal grill, it's assumed to have 75% free area.
Okay,
So
times
times 0.75.
Okay, 126.
Okay, so we got 126 square inches.
20 by 20 times 0.75. All right, I got the next one.
Okay, lay it on us.
300 square.
Boy, now you're getting it. Is it making sense now?
Yeah, buddy.
Okay, number 11, lay that one on us.
20 times 0.25. 100.
100 square inches. Atta boy. See how easy this is?
Yeah, buddy.
It's just repetition. Go ahead and knock out 12 for us.
15 times 20 times 0.75 because it's a metal grill, right? Yep. 225.
All right, good enough. I'll have you do one more and then we'll pick on someone else. Number 13.
That works. 13's a metal grill as well. So times 0.75 equals 135.
Very good. All right, my buddy Carlos, can you hear me okay?
Yeah.
All right, did you get this one done?
Yep. So I got 81 square inches. I didn't write down how to do it, but
Okay. I think we're all getting the gist of how we do it. And again, the example is up at the top of the page here. Okay. All right, what'd you get on number 15, Carlos?
243 square inches.
43 square inches. Very good. What'd you get on 16?
45 square inches.
45 square inches. Good deal. Okay, so that was the first way. That's one way of doing it. You know the grill size, okay, but you got to determine how many square inches of free area the grill actually has. Because a 12 by 12 wooden grill does not have 144 square inches of free area. It only has 36 square inches of free area. Okay, so now the second sheet is a new way, a different way of looking at it. And this way they word the question different. Okay, so they tell you 100 square inches is needed. So you've determined that that's what you need. I need 100 square inches. And you want to use a metal grill. What size in square inches is required if I want to use a metal grill to get to 100 square inches? So what does that going to look like? And let's go ahead, Carlos.
So I got 133 square inches.
You got 133 square inches. That's exactly right. And how did you do it? What was the math that you used?
So since you're using a metal grill, do 100 square inches divided by 0.75, and that gives you 133.
Very good. Okay. 133. And again, the examples are up here. Okay. And you're going to see the questions asked different ways. Okay. They're going to simply, it may be as simple as this. An 18 by 18 metal grill has how many square inches of free area? Well, you use this math to figure that out. But if they pose the question to you in this way, 100 square inches is needed and you want to use a wood grill, what size in square inches is required? So what'd you come up with on that one, Carlos?
We're at number 2. I got 400 square inches.
400 square inches. So I would need a 400 square inch grill if I needed 100 square inches and I wanted to use a wood grill on that one. That's a big ass grill, right? Okay, number 3, what'd you come up with on that one, Carlos?
107 square inches.
Okay, 107, or for those of you that came up with 106.6, we just round up. Okay. All right. Okay, next one, what'd you come up with on that one, Carlos?
320 square inches.
320 square inches, very good. Okay, next one.
267 square inches.
267 square inches, or for those of you that got 266.6, you round up. Everyone understands rounding, right? It's an ongoing joke here because I had to spend 20 minutes in the class one time explaining how to round. All right, when'd you get on the next one, number 6?
Is that where you sand the
800
edges
square
off?
inches.
Wait.
Yeah, you have to sand the edges to make it round.
Mhm.
I'm sorry, Carlos, what'd you say on that one?
800 square inches.
800 square inches, man. Wood grills suck. All right, Carlos, number 9, what'd you come up with on that one?
Number 9 is, I didn't round, but I had 197.33 square inches.
Okay, 197.3, that would just be 197.
We're on 7, not 9, bro.
Is that?
You told him do number 9, but we're on 7.
Oh, I'm sorry. We're on 7, 197 square inches. Now we're on 8. I guess if I'd pay attention to where my little cursor is on my paper, I'd know where I'm at, right? Okay, number 8.
Is 600 square inches.
600 square inches. Okay, and sorry, number 7, I screwed up there. What is number 7 actually?
200 square inches.
200 square inches. Number 9, we already did. 197 square inches. Okay. All right, number 10, Carlos.
592 square inches.
592. All right, I'll be done picking on Carlos now. Let's see, who's Tim? Timothy Lloyd. Can Tim hear me and talk to us there, Kurt?
He ain't got no mic or anything. No
He ain't got no
camera
mic.
mic.
All right, never
He's at
mind, Tim. Blake, can you hear me?
Yeah.
Okay, why don't you go ahead and take over? Did you get this one done? Take us from number 11.
Got 160.
160, very good. Okay, what'd you get on the next one?
480.
480, very good. Again, if anybody got something different than these, speak up so we can talk about what maybe you did wrong on your math. Number 13, what'd you get on that one?
100.
100. Okay. Number 14, what'd you get there?
300.
300. Okay. 15, what'd you get on that?
128.
128. Very good. 16.
384.
384 square inches. All right. Anyone have any questions about those two different math formulas that you're going to have to know for the test? Okay. All right. That's why I gave you so many. Repetition. That's just repetition. It's also in the book. They talk about it in the book. Back up in the Grille section, they give you an example. So they show you some examples here. Oops, that's for, there we go. Examples for grills here. And then, of course, we just went through numerous practices. Okay, good deal. Okay. All right. Then we start getting into the heavy duty stuff. So you had a whole bunch of these diagrams you had to go through. And on test day, you're going to see a ton of these diagrams, and you're going to have to start answering questions just like we did on this one. Last time we met, we went through the first one together so that you could all have an idea of what you're going to be doing, okay? But you're going to have to know and understand the combustion air code to get through the diagrams. So because we did the first one together, I've already got all the information in there. We did that last time. So we're going to start over here on 2. And Mr. Turner, would you take us through the process on this one, starting with the total BTUs and how you figured it out and all that type of stuff?
So total BTUs in the mechanical room is 140,000 because I'm adding the furnace and the water heater together. The
Okay.
volume of the mechanical room, I have 8,000 because I'm
Okay.
multiplying 25 feet by 40 feet by 8 feet because that's the ceiling height.
Okay.
The volume of the storage room was 2,400 cubic feet, which was 12 times 25 times 8. And then it says, is the mechanical room a confined space? And I've got no, it's not a confined space. I multiplied 50, which was the amount of cubic feet that I need, times the total BTUs, which was the 140,000. And I got 7,000 cubic feet.
Okay. Does everybody understand that process? You need to be able to know this. So they're asking you, is the mechanical room a confined space? So I'm going to go back to the book here for a minute. It is considered a confined space, or it's probably better if I word this, it's not a confined space as long as you have at least 50 cubic feet per 1,000 BTUs of combined input rating of all appliances in the space, okay? Now, obviously, down here, we do not include direct vent appliances because they're not pulling combustion air. So if you had a water heater and a 90% furnace, you wouldn't add the furnace in with it because it pulls its combustion air from the outside, right? But in this case, we're talking about if all the appliances were pulling it from in there. So as long as you have 50 cubic feet per 1,000 BTUs of a combined input rating of all appliances in the space, it may be regarded as having required volume, or you can use that room for combustion air. So what Turner did in this case is he determined, no, it is not a confined space because I have 140,000 BTUs, of appliances, right? Okay, the rule says 50 per 1,000, so I take 140 and I divide that, by 1,000, and that equals 140, correct? And then I simply times that by 50, and that equals 7,000 cubic feet, okay? So that's what I need for it to not be a confined space. If I have at least that much, it's not a confined space, right? What do I have?
8,000.
8,000, okay? So do I have more than 7,000 cubic feet? Yeah, so it's not a confined space, right? Does that make sense? Is there any confusion? Am I making you more confused?
No, so we're considering that storage room is connected to the house, right?
You're considering the storage room is connected to the house?
Yeah, that's how we're coming up with the 8,000. Or no?
No, so what is the volume of the mechanical room? So Sorry, my mouse.
Mechanical room. That's what I meant. Mechanical room.
Okay, so the mechanical room, get my calculator up, is 25 times 40 times 8 is
Okay.
8,000.
So
Okay,
the 8,000 was just that mechanical room.
just the mechanical room. Okay,
Okay.
notice this is a wall, so
Yeah.
that's separated off from there. Okay,
Okay.
so just the mechanical room alone is 8,000 cubic feet.
Got it. Okay.
According to the code, as long as I have 50 cubic feet per every 1,000 BTU of appliance, I'm good. I don't
Yeah.
need to bring combustion air from the outside. Does that make sense?
Yep.
Okay. All right. They get harder as we go up, and I did that on purpose. So, okay, so that's what that one should look like. That's how you figure that one out. Okay, we're gonna go over to number 3. Okay, this one's a little bit different. Kurt, why don't you take us through number 3 and kind of explain your process you went through to figure this out, starting with what is the total BTUs in the mechanical room?
Okay, so I got the furnace at 80,000 and the water heater at 35,000. So I add those together, which I get 115 total BTUs.
Okay.
Okay, and then I get the volume room of the mechanical room. Volume of the mechanical room, I done 12 times 10 times 8, which is 960. I better double check my math while I'm doing it. And then the volume of the family room is 18 times 35 times 8, which is 5,040. And then I got the volume of the bedroom is 12 times 12 times 8 is 1152, which doesn't matter.
Very good. Thanks for throwing that in. That doesn't matter, and you're going to see that. They're going to ask you stuff like that. The volume of the bedroom doesn't make a damn difference in anything we're doing, but they've asked the question, so, and they do that to try to trick you up. Okay,
Yeah.
so what did you come up with? What was your answer here and your reasoning and your logic behind it?
Okay, so I done the total BTU, which is 115,000, divided by 1,000, times that by 50, and you get 5,750.
Okay, so that's what we would need in cubic feet. That's what we'd need to have for this room to be considered not confined, correct?
Yep.
Okay.
So that's what we need in the mechanical room. So you don't have enough in the mechanical room. So you'd have to steal air from the family room, and we're 4,790 shy. So we'd have to take 4,790 out of the family room.
Okay, so is this mechanical room considered a confined space? Let's start with that. That's going to be a yes or no question.
Yes.
Actually, the answer to that is no, because no door exists there, see?
Oh, I didn't pay attention to that part.
So if you go back to the code, rooms communicating directly with the space in which the equipment is installed may be considered part of the calculated space as long as openings between them have no doors. Okay, so that's what you've got to
pay attention to detail.
Yeah, you got to be aware of that on test day when you see these exams. Technically, yes, this is a confined space if you just look at just the math alone of this room. But where there's no door on it, you can fall back to this code. The room's communicating directly with it because there's no door there. This room now essentially can be considered part of that room. We can add those two volumes together, okay? So if I add the volume of the mechanical room and the family room together, what do I get? So my mechanical room was 960, right? Plus my family room,
6,000.
6,000. What did I need? What was the requirement that I needed so that it was not a confined space?
5,750.
Okay, so is 6,000 bigger than 5,750?
Yes.
Absolutely. Okay, so no, this is not a confined space because the door's missing. Okay, there's no door there. They're connected together. So you can use this space basically is one space because the code allows for it as long as there's no door on them. The second you put a door on there, then yes, that becomes a confined space. Okay. And that's what you need to be aware of on the test. You're going to see stuff like this, and that's what you got to pay attention to. Oh, there's not a door there, so I can assume that these spaces are connected because the code tells me that I can. Okay? So everyone with me on that? Does that make sense? Okay. If it doesn't, speak up so we can go through it. And of course, this will all be on video so that you can go back and review it. And also feel free to call or email me anytime, guys. If you're working on this and you're stuck on something, don't hesitate to call or email, okay? All right, they get harder as we go. We're gonna go over to number 4. Alan, how about you take this one for us while we wait for Jordan to get back?
Yep.
Okay.
Number 4.
Diagram number 4. So
120 BTU furnace added to 40,000 BTU water heater gives me the 160,000 for the first part.
okay.
Volume of the mechanical room, I got 1,008 cubic feet.
Okay.
14 multiplied by 9 multiplied by 8.
Okay, very good. 14 times 9 times 8. So make sure you're looking at all the information provided to you on the drawings, okay? You may see ceilings that are 9 feet or 10 feet or whatever. So 14 by 9 by 8. They're telling you here all ceilings are 8 feet. Okay, very good. What's the volume of the family room?
Family room, 23 times 40 times 8. I got 7360.
Okay.
There's a door on the mechanical room. Is the mechanical room a confined space? Yes. So
Yeah.
160,000 divided by 1,000 gives me 160, and multiply that by 50. I need 8,000 feet.
Okay. You need 8,000 cubic feet for this to be considered not confined. Okay.
Yes.
Very good. Okay. Is everyone following along with that? Does it make sense? You understand that? Okay, very good. Now we're going to start getting a little more tough here. So what'd you come up with on this one?
So
Go ahead.
if you can pull combustion air from the family room, I was struggling with how to get the math done, so I played with the app.
Okay.
And figured it out that way.
Okay.
So I have the answers, but I can't tell you how I got them because I used the app.
Okay. So
if you can pull combustion air, it's 160 square inches.
okay. So if you can pull combustion air, you need 160 square inches per opening. So you would have to put 2 openings in. Okay. So again, we go back to the good practices book and we talk about
Going away.
Okay. All air from inside the building where the space in which the appliances are installed does not meet the required volume rule, which is the case we have now on this one we're doing. We don't have required volume. The space shall be provided with 2 permanent openings communicating with other spaces of sufficient volume, so the combined volume of all spaces meets the criteria of the required volume rule. one opening located in the upper 12 inches of the enclosure and one opening located in the lower 12 inches of the enclosure. Each opening shall have a free area of not less than 1 square inch per 1,000 BTUs per hour of total input of all appliances within the enclosure, and no matter what, a minimum of 100 square inches of free area. So whatever your calculation you came up with, you can never go below 100 square inches of free area. Okay, so let's go back over and kind of go over that a little bit. You got it right. Okay, so the math that you did to get it right was you took the mechanical room, which has a, let me get my calculator pulled up here. So you took the volume of the mechanical room, which was 1,008 cubic feet, and then you're going to pull air from the family room, okay, because we determined that if we add the family room, 7360, whoops, damn it, sorry. So we've got 8,368 cubic feet that we can work with, right? That makes sense?
Yes.
And in order for this to be considered not a confined space, the math we would do on it is this. We have 160,000 BTUs of appliances. I divide that by 1,000. That leaves me 160, and the rule says I need to have at least 50 cubic feet per every 1,000, right? So I times that by 50. That means I've got to have at least 8,000 cubic feet, okay? Well, because there's a door on it, I'm gonna have to put in some grills, but I gotta make sure that I have enough volume over here to get the air from there. And if I add those two together, I do. I have sufficient volume. Those two added together are just over 8,000, right? Okay. So I'm going to put 2 openings in there. And according to the code, okay, we have to have a minimum of 1 square inch per 1,000 BTUs. Okay. So we have 160,000 BTUs. So we need a minimum of 160 square inches, okay, per opening. I'm going to have 2 openings that have to have a minimum of 160 square inches of free area, okay? So what size grills, because they might ask you, typically, what size grill could I use to meet that requirement? So, and in fact, that's what they do down here next. We ask about, what if you want to use metal grills? Let's just start with a hole. What if I just wanted to make a hole in the wall to bring in combustion air without putting any grills on it? What size hole could I make to get 160 square inches?
Oh boy.
About a 10 by 16 hole. That would give me 160 square inches, right?
Yes.
There's other options. What about a 12 by 14 hole? Okay. So I could make holes, just straight holes with no grills to get air through there. So I can make a hole here that's 10 by 16, okay? Or over here, or even in the door. You could make the holes in the door, okay? All right. This is where they start getting a little more difficult. Okay, so now you want to use metal grills because you don't want to just leave a big hole in the wall, right? We want to kind of pretty it up. So we want to put metal grills on. So if you're going to use metal grills, what size grills or how many square inches do you need? What'd you come up with on that?
I just did 16 by 14, which gives you 168 square inches.
Okay, so that's one possible option. So the first thing that you got to remember is you're using metal grills. We know now that we need 160 square inches per opening. So if I'm going to use a metal grill, I'm going to take 160 times 0.75. Okay. Oops, sorry. I did the wrong formula there. Sorry. 160. If I need, I'm going to divide that by 0.75. And I've got to have something that will give me, I got to have a grill that's 213 square inches in order to get 160 square inches of free area. Does that make sense? And you're right, a 16 by 14 will do it, or a 20 by 12 would do it. Okay, so let's see, 16 times 14. Okay, so that would give me plenty. Okay, or we did a 20 by 12. Okay, that gives me what I need. Okay, everyone with me so far? This is where it starts to get a little complicated and convoluted. So we need to go over stuff, or you need me to slow down or whatever, or explain something, you just got to let me know. Okay. All right. So let's go ahead. If you want to use wood grills, what size opening do you need?
The wood grills, you needed to come up with 640 square inches.
Correct. Okay.
And so I wrote down 50 by 52.
Okay, 50 by 52. So 50 times 52. That's really big. Okay. How about if you go, oh, I don't know, let's try 60 by 12. Well, that'll get me there, right? Because I only need 644. Okay. Or I could go 20 by 34. That'll give me 680. Still giant grills if I want to go with wood, right? Okay. Did everybody, were you all able to figure that out and get those answers right? No? Okay. Robbie, where are you hung up at? Let's see if we can get you through it. I can't hear you talking, Robbie.
My apologies.
No, no worries. Don't apologize.
After I figured out is the mechanical room a confined space, and after that, I had a very hard time trying to figure out the rest of the questions. I'm just having a difficult time with this part.
Okay.
My mind's like a total blank. I don't. It's frustrating.
Okay, well, don't get frustrated. We'll get you through it. Okay, so let me see if I can put this down in a way that makes sense here. It's a lot easier to do this face-to-face in the classroom. But so you got all the way down to here. You determined, yes, the mechanical room is a confined space, okay? Because in order for it to not be considered a confined space, we've got to have 1,000 BTUs of appliances that are in there, correct? Does that make sense? You with me to that point?
Yeah.
Okay. All right. So we have 160,000 BTUs of appliances in there. Okay. So in order to figure that math out, let me get the calculator up here. I'm going to take 160,000 divided by 1,000, and then I got to times that by 50. Okay.
And we go 1,000 because it's 1,000 per cubic inch, right?
Because it's 50 cubic feet per 1,000 BTUs. Okay. So that's why I did the divide. So that tells me that my mechanical room, if I want to use all air from the mechanical room, my mechanical room has got to have 8,000 cubic feet of volume in it. But it doesn't, right? It's only got 1,008 cubic feet. Okay, so yes, it is a confined space, and there's a door on it. But the code allows us to pull air from other rooms, okay, as long as those other rooms have enough volume in them to add up to what we need. So at this point, we need to be able to get 8,000 cubic feet, okay? Well, I can do that if I add the volume of the family room into it, right? So calculator again. So if I take the volume of the mechanical room, which is 1,008 cubic feet, and I add the volume of the family room, whoops, fat finger, 1,008 plus 7,360. So if I add those two rooms together, I got 8,368 cubic feet. I now have more than 8,000 cubic feet, okay? So that, you with me there? If I add
I
those
think so.
rooms together, okay, I now have more than 8,000 cubic feet. So yes, I can combine those rooms, but because there's a door, I've got to make some holes either in the wall or in the door or whatever. I got to make some holes to connect those two rooms together, okay? And again, the code allows me to do that, and it's right here. And in order to do it, I've got to have two openings, okay, that go into other spaces that will give me the volume that I need. And those openings have to be located in the upper 12 inches of the enclosure and one in the lower 12 inches of the enclosure. And this is the key here. Each opening shall have a free area of not less than 1 square inch per 1,000 BTUs, okay? And I can never go below 100 square inches of free area, okay? So even if I came up with a calculation that said I only needed 80 square inches, I can never go below 100 because the code says that's the limit. So if I'm going to pull combustion air, so go back over here, if I'm going to pull combustion air from this room into this room, I've got to do it via two holes, and those holes can be no less than 1 square inch per every 1,000 BTUs, okay? So because I have 160,000 BTUs, and the rule is 1 square inch per every 1,000 BTUs, the math simply looks like this: 160,000 divided by 1,000 means each hole needs to be 160 square inches. So that's what I've put down here. Each hole needs to be 160 square inches. Now I could just make a hole. Simply take my Sawzall and cut a hole. And to get 160 square inches, I could cut two 10 by 16 holes, right?
Mm-hmm.
Okay. So Robbie, you're the homeowner. I'm going to cut two holes in your wall that are 10 by 16. Do you like that idea?
Yes, but I think I want some grills to make it look pretty. You know.
Grills on them, right? Yes. Yep. Okay, we want to pretty them up. We want to use grills.
Hurry them up. Mm-hmm.
I want to use metal grills. Well, there's a rule about metal grills, okay? Metal grills only have 75% of their free area. So remember the practices we did before where we converted everything?
Yeah.
So in this case, I now know I need 160 square inches per opening. You're the homeowner and you'd like me to pretty it up with some nice white metal grills. So in order to get 160 square inches of free area, I've got to divide that by 0.75, and I've got to come up with a grill that's 213 square inches. So let's see if we can type this in here. So I need grills that are 213 square inches in order to get 160 square inches of free area. Does that make sense? Because of the louver effect. Remember the louvers block it?
Yeah. I think that's part of the problem was like, how do I calculate this? So, but I think I'm following you. I am, but this is going to take some practice on my part.
Yeah, that's why I give you so many practices, and that those first practices we did that seemed so boring and where you just were doing the math calculations over and over again.
Mm-hmm.
That's how you're going to figure these out.
Yeah, it's like you said, repetition.
Repetition. Come back and watch the videos and all these practices and stuff, and you'll get it. I promise you'll get it. You'll pass this test.
Okay,
So
thank
now
you.
I know if I want to use metal grills, I've got to get grills that are at least 213 square inches. Okay. So I've got a lot of choices. Standard grill sizes like 20 by 12 is a very standard grill size. That gives me 240. Okay. So what I would end up having to do is cut a hole that is 20 by 12 and put a metal grill on it that's 20 by 12 in order to get the 160 square inches of free area. Does that make sense? Because now I'm blocking the hole with louvers. Okay.
Yes.
Another very common size is 16 by 14. That gives me 224. Okay.
That's plenty.
I need 213, 224. That's plenty. So that's all I'm doing is once I figure out what I need, and then I start, okay, what kind of grill do I want to use? Well, I know a metal grill, a 10 by 16 metal grill does not have 160 square inches of free area, right? Because of the louvers. So I've got to go to something bigger. Does that make sense?
Yeah.
Okay. All right. Let's go down and try it with wood now. Okay. So again, wood is assumed to only have 25% free area. So I would take the 160 that I need, that's what I know I need, and I would divide that by 0.25, which is simply 25%. Oops, the hell did I do wrong there? 160 divided by 0.25. Okay, so down here, if I want to use a wood grill, I need grills that are 640 square inches. That's big, right? That's a giant grill. Okay.
Yep.
Because wood is so restrictive, I've got to make a much bigger hole. So we start looking at common size wood grills. Well, I know for a fact they actually make a 60-inch, and I apologize for my mouse being dorky. They actually make a 60 by 12 wooden grill. That gives me 720 square inches. Is that more than the 640 that I need?
Yes.
Yes, so I could use
that's a big grill.
60 by 12 wooden grill, okay? I'd have to make a 60 by 12 hole in the wall and put a wooden grill in it. That's basically just putting a louver door on, right?
That's what we call a big ass grill.
Big ass grill, okay? All right. Everyone getting that, understanding it? They get harder as we go, so. Everyone feel like they want to take a break for a minute? Yeah? Okay. Let's go ahead and take about 5 or 10 minute break because I got to go use the bathroom. Okay.
Thanks, Wade. Appreciate it.
No problem. And when we come back, we're going to go to diagram number 5. And when we get back, I'll pick someone to go through diagram number 5. Okay. All right. 5 or 10 minutes, guys. All right. Looks like everyone's pretty much back. Carlos,
Yeah.
diagram number 5. Were you able to get through that one?
Yes.
Okay. Why don't you go ahead and run us through that one? Again, kind of explain your process and what you were doing as you did it.
All right, hold on. Let me turn down Robbie's thing so it doesn't.
Okay.
All right. So you have to add the BTU for the furnace and the water heater. So that's 80,000 BTUs. And then the volume of the mechanical room is 640 cubic feet. The volume of the family room is 3,600 cubic feet. And then, is the mechanical room a confined space? I put yes, because you do 80,000 divided by 1,000, that's 80. 80 times 50 is 4,000 cubic feet, and that is not enough for the mechanical room.
Very good. Very good.
All right. It says if you can pull combustion air from the family room, you will need 2 openings of what size? And it is 80 square inches because you need 1 square inch per 1,000 BTUs.
Okay. But what does the code say? Let's go back to the code. You are mathematically correct, 80 square inches. But what does the code
It's
say?
1 square inch per 1,000 BTUs.
Okay. With a minimum requirement of you can never go below what?
Oh, 100 square inches.
Can never go below 100 square inches. So yes, you're mathematically correct. You 80 square inches, but the code says you never go below 100 square inches. Okay.
All right.
Even though you only need 80, yes, your math was spot on. Okay. But you can't go below 80. You have to have a minimum of 100 square inches. Okay. So you would have to make, if you were just going to make 2 holes, and that's it, with no grills on them, you would have to make 2 holes that are 100 square inches. So we can make 2 holes that are 10 inches by 10 inches, and that would give us 100 square inches, right?
Yeah.
Or any other combination that would give us 100 square inches. But we can never go below that 100 square inch minimum. Even though your math was spot on, you only needed 80, but the code says right there, and then you got to remember that.
We got it highlighted right here too.
Right there. Minimum. You can never go below that. Even though your calculations are spot on, you got it right. But the code says they must be a minimum. It can never be less than 100 square inches, okay? You're going to see that on the real test a couple of times. They try to trick you up there, okay? So you need to make sure you remember that code. That's very important. Okay, let's go ahead down to the next one. If you use metal grills, what size opening do you need, and what does the math look like to figure it out?
So I did all these with using 80 square inch openings. So I'm gonna have to redo the math for 100. Hold on one moment.
You did them all using 80 square inches, so you're gonna have to redo your math.
Teacher's pet done messed up now.
It'd be 133 square inches you would need, and that would be.
You would need 133 square inches. So, what size grills? There's multiple choices. What size grills could you come up with that could give you 133 square inches?
So let's do 12 by what, or 13 by 10 would work, right? I know that'll only be 130. So I'm gonna say 14 by 10.
14 by 10, that'll give you 140. That'd be fine. That would work. That's a very common size grill. Okay. 12 by 12 is a very common size grill. That'll give you 144. So that's plenty good enough too. Okay. All right. And you figured that out simply by doing the 100 square inches divided by 0.75, because metal grills only are, unless otherwise noted, assumed to only have 75% of their free area, correct?
Yeah.
Okay, very good. And so what did you come up with on the bottom one, the wood grill? How would you figure that one out?
Because I did it for 80 as well. So
Yeah.
80 divided by 0.25 equals 400.
That'd be 100 divided by 0.25.
Yeah, that's right. Yeah.
400 square inches.
400 square inches.
So you need 400 square inches. So again, thinking about grill sizes, what size grill could I get that would give me 400 square inches?
Let me see. Hold on. Would a 20 by 20 work?
Yeah, 20 by 20. That's a big old wood grill, right? Big 20 by 20 grill. Okay. All right, very good. You did good. You nailed that one. Okay. Any questions anyone has on that? Is it starting to kind of make sense and click with you, Robbie?
I don't know if he could turn his down. He wasn't.
Yeah, I think I'm getting it.
Okay. All right. By the time we're done, I think you'll have it. And like I said, you can always call and email me anytime, and I'm happy to do one-on-one with any of you guys anytime on this stuff. Okay, let's go over to diagram number 6. Blake, did you get diagram number 6 figured out?
Yeah, I got a bunch of scribbles, so we'll see if I can decipher what I've scribbled out and what I've actually wrote.
Scribbles. Okay, well, let's just break it down, take it one bite at a time. Okay.
So total BTUs is 155.
Okay.
The volume of the mechanical room is 640. Volume of the family room is 2,304. So I put yes for a confined space.
Okay. Yes, you're correct. It is a confined space.
We need 7,750.
Okay. And you said you needed how much again?
I wrote 7,750.
Okay, very good. And how did you figure that out? Explain to us how you figured that out.
Well, what I have wrote down is 155,000 divided by 1,000. It equals 155, and then I times that by 50.
Spot on. Okay, so for that to be considered not a confined space, you would need 7750. Oops, I'm typing over here on the other damn screen. Sorry. You would need 7,750 cubic feet in that mechanical room for that to be considered not a confined space. So yes, it is a confined space because it only has 640 cubic feet. Okay. All right, very good. What'd you come up with on the next question? If you can pull combustion air from the family room, you will need 2 openings of what size?
Let's see, 77 and a half. Wait. No, you can't. There's not enough combustion air.
You cannot pull from the family room because there's not enough volume there, right?
Yes, you have to pull it from the outside.
Okay, we have to go to the outside. Now I want to just stop there and make sure everyone understands this. The reason we can't pull the air combustion air from this family room now is because the family room, when we figure the volume, is 2,304 cubic feet. And the volume of the mechanical room is 640 cubic feet. Okay, let me get my calculator over here. We need a total of 7,750 cubic feet to provide combustion air for this 155,000 BTUs of appliance. Well, if I add up the mechanical room, which is 640, plus the family room, which is 2304, I'm nowhere close to 7,750, right?
Nope.
So I can't pull it from there. I have no choice. I can't do it from there. I have to go to the outside. Does everyone understand that concept? Before, over here on this one, yes, we could pull it from the mechanical room because when we added it up, we had enough volume. The combined spaces, we had enough volume. But over on this guy, okay, we cannot pull it. No. The answer to that is no.
So is that the answer we're looking for, is that you cannot pull it from the family room? Because I still answered it, even though I knew there wasn't enough cubic feet in the family room.
Yeah,
I still answered it.
That's how you're going to want to answer that. If you were asked that question on the test, okay, and even right there it says, if you can pull combustion air from the family room, you'll need 2 openings of what size? Well, you can't. There's not enough volume there, okay? And you'll probably see it worded a couple of different ways, but the key to remember is there enough volume if I combine them together, okay? You got your math right, you know, but you can't technically pull it from there because there's not enough volume. Does that make sense? Okay, hopefully I'm not making it too confusing on you. So we've determined we can't pull it from the family room because we don't have enough volume. So our other option is now we've got to pull it from the outside. And you've got 3 questions you have to answer. So the first one is, if you use vertical ducts for combustion air, what size must they be? So what'd you come up with there?
38 3/4.
38 3/4. Okay. Yep. And how did you come up with that information?
Honestly, I don't remember.
Honestly, you don't remember?
No.
Well, let's go over to the code book, and it gives us some information. We are now pulling air from the outside, so we have to go over to the section of the code book that says outside air. All air from outdoors shall be obtained using one of the following methods, and they give us several different methods we can pick from, okay? So first question asked us, if you use vertical ducts, what size must they be? Okay, so the way we figure that out is we have 155,000 BTUs of appliances, correct?
Yep.
And according to the code, if we use vertical ducts, we have to have 1 square inch per 4,000 BTUs, right?
Yes.
Okay. Oops. So let me go back over to this guy and the calculator. So if I have to have 1 square inch per 4,000, I've got to take my total BTUs and divide that by 4,000. And that tells me I need 38.75 square inches, okay? So I could either do square ducts or round ducts. So what size rectangular or square ducts will get me 38.75 or bigger?
Uh-huh.
What about 4x10 ducts? Could we use 4x10 ducts? Yeah.
Yeah.
That gives us 40 square inches, right?
Yeah.
What if I want to use round pipe? What size round pipe would I need? There's a mathematical formula to figure it out. It's called pi r square, but here, I'll just show you the easy way to do it. So right up here in the book, it says round duct sizes in inches. Okay. We determined that we needed 38.75. So if I come over here, will 7-inch do it? Will 7-inch pipe? No. So will 8-inch give us at least 38.75?
Yes.
Okay, so I could go to an 8-inch pipe. So I don't even have to do the math pi r square. I can just go right to this page 80. And if you are asked what size round duct do you need to meet that requirement, it'll tell you right here. Okay, they've already done the math for you. Okay, so if we were going to run it in round pipe, we would have to use 8-inch. Okay, that makes sense? Okay, now the next one, if you use horizontal ducts for combustion air, what size must they be?
Let's see. So it would be 155,000 divided by 2,000. Pull out trusty old calculator again. 77.5.
77.5. 77.5 square inches. Okay, and the reason you use 2,000 was because they're asking now if you're using horizontal ducts. So we go down to the code for pulling outside air. Let's see, that's vertical or direct. That doesn't fit with what we're doing. We're using horizontal ducts. Horizontal. If I use horizontal ducts, I have to have 1 square inch for every 2,000 BTUs, okay? And so he simply did the math of, we had 155,000 BTUs divided by 2,000, tells me I need 77.5 square inches, okay? So what size square duct might get me there?
Would that 4x10 work?
4x10 only gives me 40 square inches, and I need 77.5.
So an 8x10.
8x10, okay?
Yeah.
That'll give me 80 square inches. What about a round pipe? What size round pipe do I need to get 77.5 square inches?
Page 80, it is a duct.
Go back up to page 80. Oh, I've got to go with 10-inch ducts, right?
Yep.
Okay. All right, very good. Okay, let's go back to the last one. If you use direct openings, so direct openings is just a hole through the wall to the outside. So what would you have, what'd you come up with there?
It's 38, or yeah, 38 3/4.
Okay, so 38.75 square inches. And again, the reason we did it is because we go back to the code. Says if we're pulling all the air from outside, vertical or direct, we need 1 square inch per every 4,000 BTUs, correct?
Yep.
Guys, the math he did was this. We had 155,000 BTUs. And according to the code, if we're going to go direct, we need 1 per 4. So I just simply divide my total BTUs by 4,000. And that tells me I need 38.75 square inches. So if I were going to use a rectangular or square duct, I could do 4x10. That gives me 40, right? And if I want to know what size round duct I can use, I'll spare you the pain of the formula of pi r square and just refer you to this page. Find the one that's bigger. You can never go smaller. So 7-inch is close, but it won't work. I've got to go to 8-inch and have to use 8-inch pipe. Okay. All right. Starting to make more sense now, Robbie? Good. All right. Diagram number 7.
I got a question, Wade.
Yes, go ahead.
So when we're venting to the outside, a lot of times we have, especially on existing stuff, you see where they have just an air grill. We have to account for the size of that air grill that we're putting on, right?
Absolutely.
So in some cases, we might have to change the grill size that we're using, correct?
Yeah, so here's an example of something I've seen before, well, quite a bit.
So if
So
my question is like, if it's calling for X amount of air and we size it for that duct, do we have to increase because of the size of the grill that we're using?
absolutely. Yes,
Okay.
thank you. That's where I was going next. So
All right,
like
cool.
back to this example. If I ran a 4x10 duct, yeah, that'll give me 40 square inches. But if I put a grill on that duct, do I have 40 square inches now? No, I don't. I've got to account for that. Okay. I can't tell you how many times I've seen that happen. Yeah, they got the right size duct in, but now you put a grill on it, the grill becomes the choke point or the restriction, if you will. And now you don't have enough free area because of the grill. If you take the grills off, you're good. But how many homeowners want a hole in their wall with no grill on it? So you got to think about that. If I'm going to be putting a grill on it, I've got to make my duct bigger to accommodate the grill. I can't tell you how many times I've seen like 8-inch pipe ran and they put a 12 by 12 square grill over it to make it look pretty. Well, they just reduced their 8-inch pipe it's not giving them the volume anymore because they stuck a grill over it. But because the grill was 12 by 12, they thought that would work. But think about that, a 12 by 12 square grill over an 8-inch round hole. How much of that grill is not even contributing to the hole? I mean, you know what I'm saying? So yeah, you're spot on there, Isaac, spot on. Okay, diagram number 7. Since Isaac was spot on, we'll let him, did you get that one done?
No, I didn't get to any of these yet.
Okay, I know you got in a little late and we're a little behind, so don't sweat it. Let's see, who haven't I picked on yet? Hell, I don't know. Kurt, you're doing real good at this, so why don't you take us through diagram number 7?
Okay, so my total BTUs is 135,000. My volume of the mechanical room is 1,120. Volume of the family room is 3,456. I need 6,750.
Okay.
And then you have to pull it from the outside.
Okay, so the answer to this question, is the mechanical room a confined space? The answer is yes, because you need correct?
Yeah.
Okay. All right. So next one. If you can pull pressure.
Outside.
Sorry, say that again.
I put no, you have to pull it from the outside.
Okay, again, the answer is no, because I don't have enough volume in the mechanical room, correct? So I can't pull it from that, or I'm sorry, I don't have enough volume in the family room. So no, not enough volume. So now you have no choice. You've got to go to the outside, right, Kurt?
Yep.
Okay, so if you use vertical ducts, plural, you want to remember that, okay? Vertical ducts for combustion air. What diameter round duct must they be?
I didn't do the diameter, I done the volume, which is
Okay.
135,000 and divide that by 4,000, which you get 33.75.
Divided by 4,000 equals 33.75. Okay, and the reason you used 4,000 was because of the code. Oops, down here. Going the wrong way. Outside air. Okay, and we're vertical. So the code is 1 square inch per 4,000. So that's why you did the math this way, right?
Yep.
And they're asking you at the end of the day, what you have to answer is what diameter round duct must they be? Well, I can teach you guys a formula, or I can tell you, go to page 80. Okay. And right here, so I need 33.75 square inches. Will 6-inch duct give me 33.75 square inches?
No.
Okay. Will 7-inch duct give me 33.75?
Yes.
Yes. So I can use two 7-inch round ducts. So the correct answer there is 7-inch round duct. Okay. Pretty easy to figure out. You whipped right through that one. Robbie, is it starting to click now?
Yep, it's starting to work in my head.
Okay, good deal. Good deal. Don't worry, we're gonna get you through this, man. Is everyone else okay? Is there anyone else who's struggling? Okay. All right, very good. Okay, Kurt, take us through the next one. If you're gonna use horizontal ducts, what diameter round duct must they be? So what was your process?
135,000 BTU divided by 2,000.
Okay.
I got 67.5.
Okay, and why did you use 2,000?
Because the book told me to.
Because the book. Okay, the code. Okay, so let's go find that code. And this is the trick to this, guys, just knowing where to find the code, and so you know which math to do. So, horizontal. If you use horizontal ducts, I have to have 1 square inch for every 2,000 BTUs. Okay. So I come back over here. Okay. And 135 divided by 2,000 equals 67.5 square inches. So what diameter round duct must they be? I can either do some math, or I can go back up to page 80. Okay, and what duct will give me my 70 or 67.5 square inches?
10.
10 inch. Got to use a 10-inch duct. Okay. All right. Very good. Okay. So answer to that is 10-inch round. Okay. If you use direct openings with metal grills, what size must they be?
I think I got, let's see, I done 135,000 BTU divide by 3,000.
Wait a minute. Let's go back to the book here. So direct openings. Okay. So let's go find the code for direct. So we've got to go to all air from the outside. Vertical or direct?
Okay.
1 inch per 4,000. Okay. So vertical or direct. Okay. You probably went and used this code. Horizontal. Okay. Or no, you said you went to 3,000. You went to the one opening.
Openings.
Okay.
Outside their openings.
This is important. This is key. If you use direct openings, plural, and they will try to trick you on the test with that. It might say if you use a direct opening, that would be one opening, right? But in this case, they're asking if you use direct openings, which is plural, that means there's 2 of them. Okay, so that would be, whoops. So vertical or direct, you went divided by 4,000. That equals
33.75.
75. Okay, and now they're metal grills. So we've got to do what to them? Because
Divide
metal,
by 0.75.
right, divide by 0.75 because they're metal grills. That equals 45 square inches. So now I've got to come up with 2 metal grills that are 45 square inches. So what common size metal grill could I get that's going to get me 45 square inches or bigger? Let's see, 4x10 is super common, right? Nope, that doesn't give me 45. How about, let's see, 6x8 is really common. Hey, 6x8 will give me 48. That'll get me there, right?
Yep.
Okay. All right. That plays back into what you're talking about, Isaac, where if you're going to put a grill on the hole, then yeah, you got to make the hole bigger. Okay. Makes sense? Okay, I think you guys are picking it up pretty good. All right. Any questions about that one? Okay, we got one more to go over. I know we're going long, guys. Normally when I do this class in person, combustion air is like a solid full day class. So I know we're going long. If you got to cut out, you can cut out when you need to. It will be all on video. But yeah, combustion air is a big chunk of the test, and so we've got to be good at it. Okay, this is our last one. Let's see. Blake, you want to take us through this last one?
I'll see if I can hack my way through it.
You can hack your way through it? Okay, well, let's do it. That's what this is all about. It's about learning.
So the total BTUs is 115,000.
Okay.
Then the mechanical room only has 768. The family room only has 300 or 3,840.
Okay. E.
And I
Okay.
put yes for confined space.
Okay. Why is that?
Let's see. It needs 7,750 cubic feet. And
Okay,
you only roughly
you don't have enough volume, even though there's a door missing there, and you can include that in the space. There's not enough volume there, right?
Yep.
Okay, all right, very good. So now we have no choice because we don't have the volume that we need, even though the door is gone, there's no door, but we just don't have the volume. We have no choice. Now we have to go to the outside to bring combustion air in, right?
Yes.
Okay, so if you use vertical ducts for combustion air, and again, ducts, plural, 2 of them, what diameter round duct must they be?
let's see, where is it? There it is. So 115,000. Divide that by 4,000. That equals 28.75. Let's see. You'd have to use 2 7-inch round ducts.
Okay. 28.75 square inches. And to save you the pain of having to do extra math, you just go to page 80. I've already done the math for you. Okay. And we come up with, yeah, 2 7-inch round ducts will work because we need 28.75. 6 inch isn't quite big enough. You can never go smaller, always go bigger. Okay, good deal. Okay. How'd you figure out this next one?
So 115,000 divided by 2,000 for horizontal. And that equals 57.5. And you would need, on page 82, 9-inch round ducts.
Okay, so over here, need 9-inch round, and up here we need 7-inch. Okay, very good. Excellent. Okay, the very last one. If you use a horizontal duct, this is the key. How many ducts is that? 1 or 2?
1. This one threw me off.
Okay, if you use a horizontal duct, so they're saying you have 1 duct for combustion air, what diameter round duct must it be, and what other factors must you consider when using this method? Well, let's go look at the code and see what the code says. The code will allow us to use 1 duct, okay, as long as we meet certain criteria. So, see, we're not doing 2 openings, so that doesn't apply. Horizontal, that's still 2 openings. 1 opening. So 1 opening says I need 1 square inch per 3,000. The confined space shall be provided with 1 permanent opening located within the top 12 inches of the enclosure. The opening shall communicate directly or by duct to the outdoors. All the appliances in the enclosure shall have a minimum clearance of 1 inch on the sides and back and 6 inches on the front. The opening shall be a minimum of 1 square inch per 3,000 BTUs of total input rating of all the appliances in the enclosure, and not less than the combined cross-sectional area of the appliance connectors in the confined space. That is a mouthful of stuff, isn't it? Basically, it boils down to this. We have 115,000 BTUs, okay, and we divide by 3,000 because we're using the 1 opening method, the 1 opening code, and that equals 38.33 square inches. So now, what diameter round duct must it be, and what other factors must we consider? Well, we just go back to the code. We go up to page 80 real quick to find out what diameter round duct we need. Okay, so we got to get 38.33. Hey, 7-inch will do it. Gives me 38.48. So I can use 1 7-inch round duct, and then I just have to make sure that it meets all the other requirements that are listed for the 1 pipe method. In particular, the clearances. I've got to have a 1-inch clearance on the sides and back and 6-inch clearances in the front. So that means that the furnace has got to have clearance around it. I've got to have 1-inch clearance around the sides and the back and 6-inch clearances in the front, okay? In this last section here, the combined cross-sectional area of the appliance vent connector, you will never run into that issue. So basically you can pretty much ignore it. If you ever run into this, call me, okay? But you do need to remember this, the clearance around the appliances, okay? All the appliances in the enclosure shall have the minimum clearance. So you can't have the furnace smashed up against the wall or anything like that, okay? All right, that was a lot of combustion air practice, okay? How you guys all feeling?
I
I
got
have
a
a question.
question. Oh, go ahead,
Okay.
Carlos.
All right, so on these pages, the question I kept on getting wrong is it says if you can pull combustion air from the family room, you will need 2 openings of what size? And you said that the right answer is you cannot, because there's not enough volume. So is that how it's going to be asked on the test? Is like that because it's not asking can you pull combustion air or can you pull air from inside from the family room? It's asking if you can.
Yes, I understand exactly what you're saying. And yes, it is intentionally they are trying to trick you or trip you up, okay? So at least that's the way it used to be on the old exams. The new exams, I've heard that they've kind of taken some of the trickiness out of the questions, but that's how it was on the old exam. That's a trick question. You did the math right, you got everything right. The problem was there wasn't enough volume there. So technically, no, you can't pull from that room, and that would be the right answer. And that's how they try to trick you. I think
Okay.
questions like that are kind of shitty because, yeah, you got the math right, you did it right, but when it comes down to it in the real world, if an inspector was to go out and look at that, no, you couldn't pull combustion air from there. Does that make sense? Does that help answer your question?
Yeah.
Okay. So just be aware of that. Think of it. Think of the end result. If an inspector comes out to look at it, the inspector is going to default to this. What does this book say? Okay. So kind of go into it with that mindset, and maybe that'll help you. Because yeah, you were mathematically correct in what you did, but
Yeah.
you couldn't do that because there wasn't enough volume in there. Okay. So
Alrighty.
hopefully they've got rid of those trick kind of questions. Because yeah, I agree with you 100%. It says, well, if you can pull combustion air, so in your mind you're thinking, okay, well they're asking me if I can, what size? Well, I get it, but the answer at the end of the day is no, you can't because there's not enough volume. Okay. Hopefully that helps clarify that. And my understanding is they've got rid of some of those trickier questions like that. So. Any other questions about combustion air and stuff? I want to show you a real quick PowerPoint. Well, it's not super quick, and then kind of get us going on our next stuff. The next stuff we're going to be working on is venting, and venting is another big deal. We're going to probably spend a lot of time on venting in our next class. We'll probably end up breaking it into maybe 2 or 3 classes to get us through venting because it's really complicated and involves a lot of stuff. But questions on combustion air and anything
Yeah,
else on
I had one more on that last problem we were looking at.
Uh-huh.
We, as far as like bringing air in from the outside, we're gonna want to separate that mechanical room from the rest of the house at that point, right? So we don't want to take into account any of this makeup space, right? Or any of
Yeah,
the space in that separate room.
exactly. At the end of the day, I mean, so adding combustion air is exactly counterintuitive to what we're all taught to do. We're taught to make houses tight and seal the holes up. But if we make them so tight and we have an appliance in there that needs combustion air, we've got to bring it from the outside. So we've got to make a hole in there. So ultimately, we would like to have this sealed and isolated from the rest of the house. Can we always achieve that? No, not always. Okay. But we've got to meet the code. If we don't have the required volume in there and we've got to pull it from the outside, we've got no other choice. We've got to pull it from the outside. The other way to get around that is just don't use appliances that require combustion air to be pulled from the house. Use direct vent appliances. Like I said at the beginning, if I was king of the world, we would be using direct vent appliances on everything. Water heaters, everything would all be direct vent. But I'm not king of the world, so sometimes we still have to use atmospherically vented appliances, which require combustion air. So, does that answer your question to your satisfaction? All right, awesome. Okay, so I'm gonna pull up a PowerPoint real quick here and minimize that. So I'm gonna go through this. This is what your book should look like. Now, of course, yours is not gonna say instructor's guide on it, okay? Because I'm an instructor, but yours, this is your cover page, okay? And then when you open it up, this should be your first insert, the cover page for physical properties of natural gas and combustion analysis. Okay. And then you've got your physical properties of natural gas, the little reading thing that you did. Okay. And again, when you find the answers to stuff, guys, highlight them in here. So, because this is what you're going to take into the test with you. If you walk in with a whole bunch of papers wadded up in your pocket, they're not going to let you in with those, but they will let you in with a nice, well put together study guide, okay? After that, you should have this book in there. You should have all got this book, okay? And you have chapters that you had to read and go through in there. You had the tests in each of those chapters, and if you forgot which chapters you were supposed to read, right back here, 1, 2, 3, 6, and 8, and answer the chapter review questions, okay? And if you have that book in there with you with those chapters read and highlighted and the review questions done, that's going to help you big time on the actual test, okay? You have resources to turn to. Then you have your physical properties of natural gas kind of pre-test, okay, with all your answers. And note where I always note where I find the answers, so I can go back into that book if I need to. Okay, I know where I found that answer. Page 14, I can go back and verify. And you'll see these questions asked in different ways, but you know, they're basically the same thing. If they're asking you about products of combustion, well, I know where I can go find it, page 16 and 18 of that book, okay? So if you're putting this together in order, like you should be, you're gonna have a nice, well put together book, okay? That's easy to find everything. And then our next one is our green sticker safety, your cover sheet for that. And then we had our green sticker safety little practice exam and all the answers, where we found the answers, okay? Gas pipe installation and sizing. Of course, we had a little practice exam for that. Again, where did you find the answers? Our gas pipe sizing practice instructions, how to size gas line. And then you've got your converting BTU to CFH practice. Okay, your gas line schematics. Y'all remember the gas line schematic fun we had? Okay, so have all your schematics in there in order. Appliance installation, we just went over that today. Okay, again with your little exam, and notice I've just noted where I find the answers, okay, because some of the answers are very long, but I know now when they're asking me about something in appliance installation, I know where I can go to quickly find the answer. Page 65 or the IFGC section 306. That's what this is all about, is just knowing where to find the information, okay? All the answers to every test question are in these books and these notes you're taking. And we have our combustion air section that should be next in your binder. Okay, our combustion air practice. And then of course our grill sizing practice. Okay, the reason I made you do so many of them is the repetition, okay? And then all of the combustion air practices that we just went through. Have those all in there, okay? Appliance, vent, and design. So I sent you an email yesterday with this cover sheet. So that'll be your next cover sheet. And then this book, I sent you a PDF copy of it. You can get hard copies of it. You can order them right from Simpson Duravent, and they'll send you like a case of them for free. If you'd rather have a hard copy, just get a hold of these guys and tell them you want copies of their sizing book or the PDF I sent you. You can work off of it. It will work just fine. It's exactly the same thing. Okay. And then you have a vent sizing and design little exam that I sent you. And that's as far as we got. So that's kind of how your book should be set up. So your homework now that we've gone through combustion air stuff, the homework that I sent you, the vent sizing handbook, you need to read this book and read it at least to page 40, okay? So at least get to page 40. Beyond page 40, we get into some multi-story, multi-housing stuff that's not really applicable to the test you're going to be taking. There may be 1 or 2 questions in the entire test about multifamily venting. So if you get to at least page 40 of the book, okay, that's part of your homework. And your other homework is this vent sizing and design practice sheet. You're going to need to use the good practices book, the IFGC, and this vent sizing handbook in order to answer these questions. Okay, there's 28 questions, and the only way you're going to find the answers are in these 3 resources. Okay, so when we meet again, that is your homework. Read this book to at least page 40. Okay. It's got the gamma charts in it, the sizing charts, because we're going to be working off the sizing charts here pretty quick. It explains how to use them. I've got a whole bunch of practices for sizing flues, so don't worry, you're gonna get bored to death with flue sizing practices. But when we meet again, I want you to have read this book at least to page 40. Highlight anything you think is important, okay? And complete this vent sizing and design practice exam. Again, 28 questions. The only way you're going to find the answers is by looking through these 3 resources, okay? Any questions before we end today's meeting? So Thursday, December 3rd, that'll be next Thursday. Does that work for everybody? 8 a.m.?
Yes.
All head nods and yeses?
Yes.
Okay, Thursday, December 3rd at 8 a.m. we will have our next RMGA study group. So remember, your homework for then is to have read this vent sizing handbook at least to page 40. Feel free to read the whole thing if you want, but the pertinent information you need is up to page 40, and have this little practice exam finished with the answers and where you found the answers, okay? I will do my very best to have this recording posted by the end of today. Excuse me. These long meetings take a lot of time to render the video. If I don't have it up by the end of the day, I will have it tomorrow or Monday at the latest for you, okay? All right, guys, thanks for showing up and participating and your patience. And again, any of you, if you have any questions, if you're struggling, that's why I'm here. Call me or email me. I will work with you one-on-one anytime you want, okay? All right on, guys. Go forth and weatherize.
Thanks, brother. We'll see you again.